Perhaps the radio transmission got from Proxima Centauri? There are billions of planets in our system that could uphold life, and the James Webb Space Telescope could assist us with finding them. The JWST is the most astonishing thing that people have at any point done to check space out. Researchers believe it will be much stronger than any space camera ever sent off by humans and will allow them to study faraway objects in a way that has never been possible before. The JWST will look at Proxima B in space to check if it emits produced light. Yes, you heard that right. Utilizing the types of rockets we've previously sent, like New Horizons or Voyager 1 and 2, you had to send them before the first humans left. Researchers remain curious as to whether the lights coming from Proxima B are from different planets. What could it be that the JWST will find when it draws nearer to the alien world, and how might it change our lives? Come with us as the JWST makes a colossal viewing of artificial lights on Proxima B that could change everything. Are there others in space? People have been posing that question for a long time, but where to track down intelligent life beyond Earth is a much harder inquiry. Many worlds in the universe would make good places to search for things. Researchers say that Proxima B, a world that has yielded some very surprising findings, is the biggest one so far. Why are researchers investigating Proxima B? Where is it? What unnerving things have been tracked down about this planet, and how did the new James Webb Space Telescope uncover them? The stars will be bright when you gaze up at night, but you probably won't see the planets that revolve around those stars. It isn't feasible for us to see these planets with our own eyes. They are called exoplanets because they are not in our solar system. Even with telescopes, this film shows another justification for why it's difficult to see them. Specialists say that some exoplanets may have the right circumstances for life, so these distant worlds might harbor life from different planets. Researchers have always been keen on these planets, but their investigations have been limited by the tools they have utilized. There is another player around, though, the powerful James Webb Space Telescope. Researchers aren't too optimistic to imagine that they will see aliens walking around, even though it would be perfect to see genuine footage of them. Rather, they search for signs that these worlds have life. But what exactly tells scientists that a planet has living things or, on the other hand, aliens? Researchers have been trying to find life on Proxima B since it was discovered. Its parent star, Proxima Centauri, is part of a peculiar triplet of stars that scientists are still trying to figure out. All three of these stars are Alpha Centauri and share a gravitational place. Researchers don't know whether Proxima Centauri is orbiting the other pair or just passing by. You needn't bother with a telescope to see Alpha Centauri. All three of these stars cooperate to make the third brightest star in the sky. Proxima is the one that is closest to Earth. They are 4.37 light-years apart and 4.22 light-years apart, respectively. This star is difficult to see since it is smaller and less bright than the other two. It isn't possible to see red dwarfs with the unaided eye. Proxima B has a tiny orbit around its star at 4.6 million miles. This planet orbits its parent star, which is around 5% of the space between Earth and the Sun. Earth is 93 million miles from the Sun. People on Earth need special tools to take a gander at Proxima Centauri, even though our Sun is a major bright star. In Proxima B is in the habitable zone of its parent star, which means that liquid water may be there. The habitable zone of Proxima Centauri is very close to its parent star, which is not quite the same as our Sun. Proxima is cooler than the Sun, so this is the case 4 light-years away. Researchers have found Proxima B, the nearest planet that seems like Earth. That doesn't mean we can send people there anytime soon. No Earthlings will go to Proxima B anytime in the near future because the technology we have now means that investigating the world could take thousands of years. You will not be able to see Proxima B if you gaze directly toward Proxima Centauri. It doesn't pass in front of it. This makes it hard to figure out. Nobody knows whether Proxima B's orbit is generally round or exceptionally elliptical. Space experts also feel that Proxima B probably hasn't always been habitable. If it formed in the way it is now, it used to be hotter before Proxima Centauri became a main sequence star. Proxima B may have started too close to its star and remained there for a very long time. It is extremely hard to find exoplanets like Proxima B since they are so difficult to see. researchers need to get creative to sort out what they are. This is also why the first exoplanet wasn't found until 1995, despite the fact that experts think there are trillions of them in our galaxy alone. There may be many more than stars, and a lot of them are believed to be about the size of Earth. It was a hot gas giant that was around half the size of Jupiter and discovered in 1995. In its 4-day trip around its parent star, it pulled so hard that cameras on Earth could see it wobble. Basically, they knew what to search for by then. The wobble technique discusses 51 Pegasi b. The radial velocity of the stars is tracked. When a star draws nearer or farther away, its light frequencies compress and spread. The wobble is caused by the pull of a planet's gravity. Exoplanets can also be found with transit discovery. The Kepler telescope made it famous, and you had to focus on a specific region of the sky for years. Kepler looked at a piece of the sky with 150,000 stars. It was searching for small drops in the light from the stars that were caused by planets moving in front of them. The mass and dip time of the guiding star can be used to figure out how large the planet is. Transit spectroscopy is another method for searching for exoplanets. For this technique, researchers look at the light that stars emit after passing through a planet's atmosphere. Researchers can determine what's in the planet's atmosphere by analyzing this light. In a way, this process is like separating light into its parts by passing it through a prism. It provides us with information about the chemicals that are in the atmosphere. Two additional ways are gravitational microlensing and gravitational astrometry. But now that the JWST is going, researchers have the best tools ever for finding exoplanets. One of the main missions of the JWST is to search for life on exoplanets that are not Earth. The gigantic telescope was launched at the end of last year for $10 billion, which is a massive leap from the budget of $1 billion. It was made with help from over 300 gatherings, including schools, by NASA, the European Space Organization, and the Canadian Space Organization. The mirror is the initial segment of the JWST. The largest mirror ever sent into space is 21.3 feet, 6.5 meters, across. It's a part larger than the Hubble. The mirror on the JWST is made of beryllium that has been coated in gold. There are more than 100 engines that move the mirrors on its 18 octagonal pieces, which are basically as large as huge tables, to zero in on things. JWST utilizes long red bands, primarily infrared ones. This means that the light from these sources has a longer frequency. JWST has 4 instruments that can capture infrared signals clearly. The instruments on a spacecraft transport are kept in graphite composite boxes. It's where the motors, computers, and communications for JWST are kept. Its brain and heart. The transport has an immense sun shield and a cryocooler that cools its parts with helium to -236 degrees Celsius -393 degrees Fahrenheit. Heat can destroy the transport's parts and make the mirror tumble off. The launch rocket couldn't find any alternate method for holding the JWST sun shield, so it was folded up and sent into space. The sun shield opened up to the length of a tennis court during the initial 14 days of the observatory's journey to its final position. Between the metal and silicon layers, there are 5 layers of Kapton polymer that block sunlight and heat in the sun shield from the JWST. The sun shield generally blocks the view of the sun toward the south. Utilizing the travel strategy, the JWST will search for life on different worlds in the universe. Coronagraphs on Webb will take direct pictures of exoplanets near bright stars. An exoplanet is a point, not a scene, but researchers will learn about that spot's variety, the way it changes in the winter and summer, vegetation, climate, and more, by utilizing the JWST to take a look at it. Obviously, scientists are always keeping watch for light or radio signals from intelligent extraterrestrial species. SETI says that its researchers utilize the Allen Telescope Array, which is made up of 42 radio-receiving antennas, to look for signals from the 20,000 closest red dwarf stars in the area, using a range of radio bands. This is just half of the journey for researchers who are looking for extraterrestrials. Any sort of life is welcomed, indeed, even microorganisms. This is because even the smallest microorganism on a distant world could convey a chemical signal that our powerful telescopes can detect. Assuming there was no life, gases in the atmosphere might have caused this. Oxygen might really mean that there is life on a world. Researchers are consistently keeping watch for new gases or mixtures, like water, in order to find life. However, they have to be cautious because these mixtures may not have a say in living things. Their sources and cycles might be totally different. So why would researchers like to dive more deeply into Proxima B? To understand this, you need to know where it is. The star Proxima Centauri is 4 light-years away and is our closest neighbor. It's surrounded by planets that move around it just like our Sun does. Proxima B is one of the planets. It was found in 2016 and has been fascinating researchers since. They have also tracked down Proxima C and Proxima D. However, Proxima D needs to be confirmed. A valid justification for Proxima B's consideration is that it has a mass about equal to Earth's. The planet might have liquid water and life since it is in the habitable zone of its star. From a scientific point of view, Proxima B could have liquid water and be a rocky world like Earth. Proxima B orbits a star, which is something that Earth and the alien world have in common, but it's not as bright or as large as our Sun. The exoplanet is tidally locked and rotates at the same speed as its star. This means that on both the light and dark sides, one side is constantly facing the star, and the other side is always facing away. Nobody knows for sure if Proxima B has clouds, water, carbon dioxide, and rock, the building blocks of life, on its surface. If it has an atmosphere, the planet is extremely close to its star, so close that it only takes 11 Earth days for it to complete one orbit. The temperatures on the planet's surface are estimated to be between -90 to 30 degrees Celsius, -130 to 86 degrees Fahrenheit. In 2016, researchers utilized HARPS, an older spectrograph, to find Proxima Centauri B. However, the world's most detailed spectrograph confirmed what had been found. Any concerns were settled by Coffey's 63 spectroscopic perspectives on Proxima Centauri in a year. In numerous ways, Proxima B is similar to Earth in size. Initially, researchers conducted extensive investigations and discovered that Proxima B is 177% greater than Earth and more like Earth than they suspected. People used to think that Proxima B was 1.3 times heavier than Earth. You would age faster on Proxima B than on Earth since it orbits its Sun in 11.2 days. Earth's observations show that Proxima B is tidally locked to the Sun. This means that one side of the star is always facing it, creating dark and bright sides, much like the Moon and Earth. The satellite is hidden from us on one side. Proxima B orbits within a system of 3 stars, along with 2 additional planets. The additional 2 planets are harder to study since they don't pass in front of Proxima Centauri. The spiral speed method was used to find them. This technique shakes the star based on the planet's gravity. The positions of Earth and Proxima B are about the same relative to their stars. Both of them reside in the Goldilocks zones of their stars. The Goldilocks zone is the region around a star where living things may be able to survive. About 2/3 of Earth's energy comes from Proxima B, which orbits its star 1/12 as far from its Sun as Earth does. Researchers think Proxima B has life because the star isn't extremely bright and the bodies are close to one another. Its Goldilocks zone makes me consider that liquid water is essential for life. X-rays, strong UV light, and particles can separate gases and fluids, making them volatile and able to escape into space. In contrast, visible and infrared light warms the Earth since Proxima B receives more radiation on Proxima B compared to Earth raises interesting questions about its potential for hosting life. Astronomers have utilized state-of-the-art devices and observations to learn about the past of Proxima B's planet. This research aims to determine how much gas and liquid is still on the world. They found that Proxima B has been hit by multiple times more high-energy radiation than Earth, somewhere in the range of 7 to multiple times more since it was formed. Before we arrived, Earth was hit with stronger radiation, which contributed to this phenomenon. Researchers estimate that Proxima B might have lost about a sea's worth of water in the first 100 to 200 million years after it was formed. What happened later is still under investigation. It's conceivable that this world, like Earth, continues to lose gases from its atmosphere, or it could have retained the majority of its atmosphere and liquid water on its surface, which would make it potentially habitable. Scientists have found clues about where most of Proxima B's water may be, which could help us understand its habitability. Through a complex 3D model, various climatic compositions and water data indicate that liquid water might be available on the planet's surface in the sunniest spots, such as the side of the equator facing the star or in a tropical belt. What if there is already life on Proxima B? There is a current theory suggesting that a consistent stream of solid radiation from its host star could assist in the development of life on the day side. This is because Proxima B is only 4.5 million miles from its star, which is multiple times closer than Mercury is to the Sun. Radio astronomers have also received radio waves coming from Proxima B, but they believe these were just caused by natural interference. The side of the world that doesn't receive radiation is generally dark, so any human civilization living there may need solid mirrors or LED lights to illuminate their cities. This need could help us find them, as a group led by Harvard researcher AI Curve suggested that the James Webb Space Telescope, JWST, could be positioned to detect LED light on Proxima B. Researchers utilized the near-infrared spectrum of the JWST and looked for LED light waves in the planet's light from its star host, checking for light curves from Proxima B and its star to determine if they could detect artificial lights on its dark side. They examined two potential scenarios: artificial lighting with the same spectrum as LEDs on Earth and lighting with a smaller spectrum that produces the same amount of light as artificial lighting on Earth. It was found that the JWST can detect 5% of the power from stars coming from LEDs. If the James Webb can find tight-band light like LED signals, it will be possible to characterize the atmosphere of the planet. Scientists will be able to use observational tools to understand how energy moves across the planet and analyze light curves to check for matches with LED light sources. A team led by LB and his colleagues utilized the JWST's exposure opportunity tool to conclude that it might be able to pick up artificial light before the observatory is launched. This tool helps space experts consider what could potentially be learned at any given time using certain variables. The researchers were able to determine whether it was feasible to measure transition values using a frequency equivalent to artificial light. It is expected that a civilization doomed to live in darkness would likely have very bright lights. The JWST is anticipated to observe lights on the permanent night side since they should be quite luminous. The JWST will suggest how to create artificial lighting using normal LEDs that are multiple times brighter than those on Earth and how to create lighting comparable to Earth's. Proxima B's results are vital for many reasons. We know there are a lot of planets out there. The Milky Way alone has a quadrillion planets. Insights indicate that each star has a planet circling around it, so there is a good chance that we will find a planet like Proxima B that could support life. People from Earth might visit Proxima B, however, they are most likely to be couriers. The Advancement Starshot is a $100 million project started by researchers and engineers to develop laser technology that will accelerate nanocraft with sails to 20 times the speed of light. We'll talk about this technology later in this film. The Advancement Starshot program aims to send groups of robots about the size of postage stamps to Alpha Centauri. If a spacecraft flew multiple times faster than light, it could reach Alpha Centauri in 20 years instead of thousands of years, like other missions. How might outsiders react to the advancement test when it reaches Proxima B? We are currently receiving signals from Proxima Centauri, which opens up a lot of possibilities. Everything began with an odd sound from the 64-meter Parkes radio telescope in Australia. Parkes was being utilized by astronomers to receive radio waves from Proxima B's stellar flares. The signal was detected by the $100 million project, Advancement Listen, which was led by Andrew Simeon from Berkeley and supported by Yuri Milner. This long-term project started in 2015 with a statement by Stephen Hawking and other notable names in the field of space science. It provides radio telescopes with additional opportunities to search for advanced civilizations in space. Researchers utilized Parkes to observe the star for 26 hours as part of their investigation of stellar flares. As expected with Advancement Listen, they marked the data so that it could be used to search for a consistent signal later. An undergraduate student and SETI developer, Shane Smith, worked as an intern at Hillsdale College. Smith analyzed the data and found that the narrowband emission was very sharp at 982.551 MHz, making it the most interesting signal they had ever found, given the number of channels it had passed through. The signal was soon given the new name BLC-1, which stands for Breakthrough Listen Candidate 1. Reports indicate that Parkes detected the signal multiple times over a few days, each time with the telescope pointed directly at Proxima. Advancement Listen employs a technique called gesturing, in which the telescope observes a target for some time and then looks at something else overhead to ensure that any signal coming from the target is genuine. 5 30-minute looks spread over 3 hours showed that this signal is coming back, suggesting that it likely originated from Proxima Centauri or another source in that region of space before it reached Earth. When the telescope was pointed away from the star, the signal disappeared. The signal appears to be coming from a 16th circle around Proxima Centauri, which is a fraction of the size of the full moon. Utilizing software filters, Advancement Listen isolates signals from deep space from those coming from Earth and satellites orbiting the planet. The project had never seen this type of contact before. Andrew Simeon, the head of the team, told Scientific American that they had passed some of their tests due to certain parameters, but he did not disclose why. Most intriguingly, the signal works in a small section of the radio spectrum around 982 MHz that is generally not utilized by human-made satellites and spacecraft. Simeon stated that there is no natural way to cluster electromagnetic energy into this type of frequency. It's possible that the radio waves are so concentrated due to a strange phenomenon in plasma physics. He believes the finding is significant. Jason Wright, a researcher at Penn State University who studies SETI, says that if the signal is not coming from Earth, it might be technology from another planet. Fill us in on what you think about Proxima B being home to extraterrestrial life.